Hi everyone, and thank you for joining us for one of our educational mobility webinars. Today's presentation has a more technical approach, and we will cover the benefits of Amazon Web Services cloud computing. Our speaker today is DecisionPoint's Vice President of Professional Services, Mark Jones. If you have any questions during the presentation, please type them in the chat box on your screen, and we will address them during the Q&A portion at the end of the session. I'm now going to turn it over to Mark to begin the presentation.
Thank you, Holly. Good morning, everybody, and welcome to our webinar today. This is a continued webinar in our series of talking about consumer prize, or applying consumer design tactics to your applications in the enterprise marketplace. Last time, we talked about coming up with a design that was very easy to use and applying a consumer-based design to your applications, to your enterprise applications, so that they were more user-friendly, so that they were able to be trained easier, and so that you could take them to market quicker. One of the things that is very widely adopted and has been very successful, obviously, in the consumer application arena is the use of cloud computing. Some of the things that are available in cloud computing today have begun to translate over to the enterprise market and are now available in the enterprise market. Some of the concerns that have been in the enterprise industry to date about cloud computing are being rectified or remedied by some of the solutions and services that are provided by some of the cloud providers. So today I'm going to talk about the benefits of cloud computing as it may pertain to the enterprise industry, and how you can use this to streamline your applications and to do a whole bunch of things that will give you some benefits immediately. The topics I'd like to cover today are flexible capacity, speed and agility, security, reliable and accessible data, low startup and ongoing costs, global availability, and then we'll talk about some other services that are available specifically for mobile applications. I'm only going to briefly touch on these topics today as we are pressed for time, but I think you'll get a good idea of what's available to you and be able to follow up on these topics. And of course, we can provide additional information at your request, or you can go out and take this information as key benefits and dig a little deeper. There's different cloud providers out there, obviously. Today we're going to talk about Amazon, or AWS cloud computing. DecisionPoint has chosen AWS cloud computing for a variety of reasons. We've been extremely happy with the services that they provide, and we have always been impressed by the number of services that come out frequently and often. So let's talk a little bit about the first benefit of AWS cloud computing, which is flexible capacity. With cloud computing, you may or may not know, but basically you set up your servers in the cloud as virtual instances, or EC2 instances. These instances you can think of actual physical hardware that might be connected to the network, but they are set up in the cloud, and they are usually behind a load balancer. The load balancer accepts traffic coming from the internet and distributes the traffic evenly among the EC2 instances. The great thing about this is that you can fire up EC2 instances on demand. And the process of starting EC2 instances is very easy, not to mention very, very fast. EC2 instances can take a variety of different shapes and sizes. They can be sized appropriately to fit your application needs. They can run on multiple different operating systems. And they really act and behave just like a physical server. An EBS volume, or elastic block store volume, is basically think of as a C drive or a D drive or any other drive that's connected to your server. You can again size these volumes specifically to your needs. And you can do things with these volumes that are more easier to be done than in a traditional hosted environment. The great thing about EC2 instances and firing up new ones and creating new ones and resizing them is that you can auto-scale for seasonal shifts in your load and demand. If you're a retail industry and you have a higher demand during the Christmas season, you don't have to scale up a bunch of new hardware or purchase a bunch of new hardware just to account for that 3 to 4 month period. Using cloud computing and virtual EC2 instances, you can scale up during the season and then scale back down when it's over. Again, I mentioned multiple operating systems are supported today. AWS has added support for Windows Server. Obviously, there's support for Linux, different flavors of Red Hat, Ubuntu, Fedora, Debian, and of course more. Here's an image or an illustration of how flexible capacity kind of works. This is a very high-level illustration, but I think it does demonstrate how easily you can add instances. Route 53 is kind of your traffic cop for AWS. It receives internet requests, and this is where you apply your DNS names to route traffic to specific load balancers or specific servers. So let's say we have a request coming in, an HTTP request coming in for yourdomain.com. That would come in through Route 53. Route 53 would take a look at that request and then appropriately send it to the appropriate load balancer. You can have 1 to n amount of load balancers. The load balancer then distributes traffic in a variety of ways, usually round robin, by sending it to the first instance available behind the load balancer. There are many different things that you can monitor within the AWS system, but of course you can monitor the CPU and the memory. If you monitor the CPU memory and detect that you have a higher than normal or whatever baseline that you set of CPU or memory detected, you can fire off a new instance. If that demand continues to be high, you fire off another instance, and so on and so forth. These instances can, again, be created on demand very quickly, very easily, and very affordably. So we talked a little bit about flexible capacity and what we could do with EC2 instances. Let's talk a little bit about speed and agility. I've hinted towards this, but you can literally add servers in minutes instead of what was formerly weeks. You can change the server sizes based on demand. And you can modify the route of incoming traffic through Route 53. In a traditional hosted or managed hosting model, and I'm sure many of you have experience with this, if you have an increased demand and you need to request new hardware for your server or request another server, you would have to put in a request to either your managed hosting provider or your internal hosting provider. You then have to sign a contract or an SLA indicating how big that server should be and how long it should last and how much it's going to cost and so forth. You then have to wait for it to be built, and then it is available. This process, in my experience, based on SLAs, can take up to 30 days. With AWS, the speed to uptime is extremely fast. There are two ways that you can create new instances. You can create them through the console or the dashboard, which is available to anyone who has an AWS account. And this is a wizard that allows you to go through, start a new instance. You basically select the type or the OS that you're going to start with. In this case, in this demonstration, you can see Ubuntu, you can see Microsoft Windows 2008, Microsoft Windows Server 2008 with SQL Server, and so forth. You select those instances, or those instance types rather, by what is called an AMI, or an Amazon Machine Image. And all that is really a representation of what that server is going to look like when it comes online. Now the benefit to that is you can do a quick start, and you can start with predefined AMIs that are basically blank slates of, let's say, Microsoft Windows Server 2008. or you can create your own AMIs that are configured specifically the way you want them. So when you fire off new instances, they are set up and run exactly like you want them and have configured them. Or you can even go to the community and borrow or use AMIs that are out there. This process of going through the wizard from start to finish, from creating a server from nothing, takes about 15 minutes. Once you have a server up, if you want to change the size of it, you go into your dashboard, you simply select the server, you shut down the server, you select change instance type, and then you can set how big you want that server to be, and then you restart the server. Again, that process takes really the only amount of time for you to click and reboot the server. You can go from a small server that's running 1 CPU and 1.7 gigabytes of memory and move to a large or extra large server that runs 2 CPUs or quad core with 7 or 15 gigabytes of memory and make that change in 5 minutes. Now that's the slow way. The fast way, in which is most dominantly used, is by doing scripting or command line interfaces. There are a number of tools out there that allow you to monitor AWS traffic or set up servers. We use an application called Chef, C-H-E-F. But this allows you to monitor your servers, monitor the usage, and then issue commands to start or change servers. But the commands themselves are very simple. If you take a look at this first command, create instance, it's really 1 line of code, 3 lines here so you can read it easier. But that is all that's necessary to create an instance and get it up and running. You supply the AMI, you supply the number of servers you want to start, the instance type or size, the key name, which is a security key that's given to you when you create your account, and then a security group, which I'll talk a little bit more about here in a second when we get to security. Resizing that T1 micro instance is 2 lines of code. You stop the instance, you supply the region name and the instance ID when doing so, and then when it's stopped, you modify the instance type. In this case, I'm going from T1.micro to T1.small, and that is all that's necessary. We've talked a little bit about flexible capacity. We've talked a little bit about speed and agility. Now let's talk about something that is probably in your mind or on your mind, and one of the things that may have prevented you in the past from going to the cloud for enterprise applications, which is security. I'm here to tell you right now that cloud computing is very secure, especially with AWS. There are a variety of security mechanisms that are involved in the entire infrastructure, but specifically dealing with EC2 instances and EC2 clusters, I want to talk about 2 points. Security groups to protect individual servers, and then setting up VPC to protect a cluster of servers. You can basically think of a security group as a firewall on a server. The EC2 instance is set up behind that firewall or within that security group. And then you set which internet traffic or network traffic is allowed to that server by port. By default, no traffic is allowed to the server. But let's say we want port 80 to come to our server so that we can display a web page. But we don't want FTP traffic and we don't want HTTPS traffic. So as long as we only supply port 80 as an acceptable port in our security group, then that is the only traffic that's going to be allowed to our instance. Security groups can be reused. So once you set up a security group, let's say for web traffic security group, then you can reapply and reuse that security group over and over and over. A security group is required to create an instance. You may recall from the previous slide where we talked about the syntax of that command line to set up an instance. I had to supply the security group. You can't start an instance without a security group, and that is just one check for you to make sure that you have security set up on your instance before it becomes online. The next layer of security, which is much deeper, is adding a virtual private cloud. I'm sure many of you are familiar with setting up server farms that are connected to other server farms. You might have an office in Oklahoma City and an office in Dallas, and you need to connect those offices together. That's done through an IPsec VPN connection through hard VPN or firewalls. This is the exact same thing that goes on with the AWS cloud. You can set up all of your instance in a subnet, and only a secure IPsec VPN connection from your firewall to that subnet will allow traffic through. If you want to set up a server farm where servers are only available to your site and only available if you're on your network, you can do that by using a virtual private cloud. Now you can take this and supply some edge cases. Perhaps you want to supply that level of security, but you want one of those instances in the cloud to be available to the internet so you can run a website or host a website. You can do that by punching a hole through it and allowing port 80 to a specific instance. The next thing I'd like to talk a little bit about is reliable and accessible data. We've talked about EC2 instances, that's one service. We've talked about load balancers or ELBs, that's another service. We've talked about elastic block storage. We've talked about security groups. Now let's talk a little bit about S3. S3 is a reliable asset storage service offered by AWS. Data is stored in unique buckets with developer-assigned keys. As a developer, if I have a web application and I need to create a place for an asset that was just uploaded to be saved, I can do that by using an S3 bucket. In order to do so, I have to assign a key to that creation of that bucket, and I get back a unique identifier for that bucket that is unique across the entire AWS infrastructure to me. That way, the only way to get back into that bucket is through both that unique key and the developer assigned key that I assigned when I created the bucket. Think of these buckets as very secure folders on a server. Up to 5 terabytes for each object can be stored for each object. You can have an unlimited amount of objects. This is extremely reliable and backed by Amazon's SLA. Access is easy. You get to these buckets through REST or SOAP. Data can be encrypted while it's sitting in S3 or while it's in transit, or both. You can create these S3 buckets based on regions. So depending on where your applications serve, you can use these buckets so that they are geographically located closer to those services. In addition to S3, we talked a little bit about EBS. EBS is primarily used for quick database or file access. S3 is a little bit slower than EBS because you're going over the internet to an Amazon service. EBS is an elastic block storage, or again like a C drive or D drive connected to your server and is immediately available. The great thing about EBS is that through the dashboard that I showed you a little taste of earlier, is you can create live snapshots of those EBS volumes and then reuse those snapshots for either backup purposes or to create a new instance that looks identical to the instances that you have running. This allows business continuity as well as ease of distribution. Here is one typical infrastructure for AWS. Again, at the top we have our Route 53 hosted zone. So incoming traffic comes through Route 53 and then is directed to a load balancer based on the domain. In this particular case, I have a hot or live zone running in East 1A and a dark or warm backup ready to go in Zone East 1B. The orange instances are the online instances, and in this case we have 3 instances that are up and running, each behind a security group, and then a DB instance that is accessible by those web instances with elastic block storage for the database. Daily, hourly, or nightly backups are taken from those EBS volumes and stored out on S3. In the unlikely event of an outage in a zone, you can restore your entire infrastructure in a matter of minutes into another zone. This is just one way to set up an infrastructure in AWS. Let's talk about costs. How much does it cost? Well, first of all, hardware costs are eliminated. Licensing costs, such as Microsoft licensing, are built in. There are micro instances which are free. This is good for development or trying out AWS. I encourage all of you to go out to AWS today and sign up for free and start a micro instance. It's a pay-per-use model. You only pay for what you need. We have our entire development environment with AWS. We run production environments with AWS as well. But our development environments, we actually schedule our EC2 instances and all of our servers to shut down at night and then restart in the morning. This saves us money. Since it's pay per use, you can schedule your servers to come on and off at load times or run times to save you some money. There's also a notion of auction or spot instances where you can have processes that actually bid for server time. Spot instances are instances that are available to everyone and shared, but you can buy space or bid for space for applications. Once you acquire the bid, it's yours for as long as you need it, but this allows you to lower your costs as well. I won't get into much more detail there. Reserve instances allow you to lower your per hour cost by reserving an instance for a period of time. Let's say you know you're going to have this application running for the next year or 2 years. You can reserve an instance for 2 years, and then your per hour cost is lower. This does not hinder you from changing the size. It doesn't hinder you from starting and stopping it. It doesn't hinder you from creating a new instance identical to it. It just gives you a cost savings by saying, yeah, I'm going to be paying for at least 2 years. So how much? Well, there's a lot of different pricing models, and they're all based on how big your servers are or what they are running. Here's a snapshot of some pricing that is provided online by Amazon. At the top, we have our Linux Unix prices for small, medium, large, and extra large. You can see we're at 0.06 cents an hour, or excuse me, 6 cents an hour, 12 cents an hour, 24 cents an hour, 48 cents an hour. Windows is a little bit more expensive because we're paying for those licensing costs that are built in, and you can see the pricing there. What about availability? Well, all this virtual stuff is great, but obviously it does run on some hardware. And that hardware are located in AWS data centers across the world. It's a good idea to choose a data center that serves as a central location for your computing requirements or your application requirements. You can always spread your applications across zones and share data between zones. There are other useful services for AWS. many services, up to 30, 35 services that I have not talked about. Useful services specifically for mobile applications, though, and we see new ones coming out every month, are SNS, which is a push notification service. So let's say your application is doing push notifications. You may have heard of Urban Airship, or you may have heard of Apple push notifications, and you're trying to decide how to do that. AWS now offers a way for you to send push notifications to your applications. There's also SES, or an email sending service. If any of you written applications and tried to send out emails, you know that a lot of times those emails can get bounced, or they have to have assigned A records or MX records so they don't get bounced, and there's a lot of things that go along with that to keep those emails from going to someone's junk folder and never making it to them. With SES, Amazon provides a service that validates your domain, validates the email address, and allows you to very easily, with 1 or 2 lines of code, send off an email to someone. RDS. RDS is a relational database service. This is basically a database in the cloud. This allows you to fire up a database instance that's specifically served and modeled for database storage and database activity and database transactions. They support MySQL, Oracle, and Microsoft SQL. With that, I'd like to allow anyone to ask questions, and Holly will field those and send those over to me. So I appreciate your time. Thank you. Any questions?
Okay, thank you, Mark. We've now reached the Q&A portion of the webinar. And one question we received during the presentation is, you showed us some costs for small, medium, and large instances. Can you give me more information about what these sizes represent in terms of memory?
Oh yeah, sure. Actually, it's even deeper than what I showed on the slide. There is a variety of different server types. There's what that's called M instances, C instances, X instances. M instances are really kind of the mainstay instances, which I showed you, and that's kind of what started. C is for like cluster computing, and then you can do H instances for high memory. But in the ones that I showed you, those are M instances, and a small instance is 1 CPU and 1.7 gigabytes of memory, 106 gigabytes of storage space. A medium is 1 CPU, 3.75 gigabytes of memory for 10 gigabytes storage, and large is 2 CPUs, 7.5 gigabytes memory. I would encourage you to go to aws.amazon.com. I believe it's /EC2 and then /instance types, or just go to aws.amazon.com and search for instance types, and that should give you the complete layout of what's available.
Okay, thanks, Mark. The next question we have is, we have a web application that we host today on a server, and it connects to another server where the database resides. How would that work with the cloud?
Well, I think the best way to make that work would be the slide that I showed earlier about the typical infrastructure. You would first want to set up a S3 or Route 53 domain for your domain name. And then you'd want to set up a load balancer and direct traffic from that domain to that load balancer. And then behind that load balancer, you would want to set up at least one EC2 instance that handled the web traffic. And that would be your web server. And really, you don't need much more than a small for web application traffic, which is very affordable. So I'd set up a small, and then I'd set up a larger instance, maybe a quad-core instance, depending on how much database activity you do, and set that up as a Microsoft SQL Server, if that's your database instance, and with elastic block storage, and store your database files on that elastic block storage. And then, of course, you've got you use your exact same environment. If you're using IIS, you deploy your code over there just like you do today on your server, and back up your database and restore it on your database instance, and you'd be good to go. Shouldn't take you very long.
Okay, great. Well, thank you all for your questions, and this concludes our webinar today. If you would like more information, you can contact Mark Jones at the email address mjones@decisionpt.com. Again, we appreciate your time today, and we hope that you will join us for more educational mobility webinars in the future. Thank you.